Alexander Fleming, he left this culture of bacteria out, and some mold happened to come in and grew. And the interesting thing was, anyone else having looked at that petri dish would have concluded, nothing unusual here, nothing to see, because molds growing in bacterial petri dishes was not that uncommon, and basically it would have normally been construed as just competition for food and for resources. But in this particular instance, this man was able to see that it was not just that. It was that the mold or the mold juice was actually lysing the bacteria. It was actually going out and killing the bacteria. Now, that didn't mean that we had an antibiotic for sure, because many things lyse bacteria, including alcohol. But drinking alcohol has not been known to cure any bacterial infections. So the mere fact that something can kill bacteria does not necessarily mean that it has this magical property of going through our body, through our bloodstream, and then going to a site of infection and actually killing bacteria. That's a very, very special property. It took quite a while after this paper was published by a team of scientists working first in the UK, and then as the war became, was more of a threat, Second World War, a lot of that work actually moved here to New Jersey and the US Department of Agriculture, and eventually it resulted in penicillin being available. The first patient treated with penicillin was in February 1942. This policeman on his day off from work scratched his face with a rose thorn, was severely infected, on the verge of dying, lost an eye, and he came back to life literally because of that first dose of penicillin, which unfortunately they didn't have enough to actually cure him. They would resynthesize this from his urine every day and to give it back to him, because they had such small quantities, but by day 4 they actually ran out of it and he died. But that didn't stop the progress, because the fact that you had this medication that could actually cure someone of a bacterial infection, which until then was probably the most common killer, whatever infectious disease causes, tuberculosis, scarlet fever, all of these were major causes of death. And this is what people then saw just a year later, the small child, with a bloodstream infection, and then you can see that, by slide 2, which is day 2, she's on the verge of dying, and then literally within a week she comes back to life. This was miraculous. We don't see kids in that situation at all, because, at least in this country, because we never let them get to that state to begin with, because we have antibiotics. But this is what used to routinely happen. I remember asking, the few people who've actually been around in the pre-antibiotic days, and they would say, look, when you had a bacterial infection, you basically just had chicken soup and you rested, and if you got better, you got better, otherwise you died. So this was usually the outcome. Pneumococcal pneumonia, standard pneumonia, which still kills the elderly in this country and young people in many parts of the world. If you had pneumonia, it was 80% chance of dying. This was one of the leading causes of death of people, just respiratory infections and pneumonia. You don't hear of people dying of pneumonia here unless they're elderly and in a hospital and they have many other comorbidities, and then they die. And this was entirely because of just penicillin alone. Now, unfortunately for us, resistance has always emerged. It was, in fact, the first paper on resistance to penicillin was published in 1940 by Ernst Chain, the folks working in Oxford to bring penicillin, to synthesize penicillin, which turned out to be quite hard, by the way. It was quite a miraculous feat that they managed to synthesize penicillin, because the original mold was not something you could treat anyone with. And finally, the penicillin that was used in all these experiments came from one moldy melon in Peoria, Illinois. So it was found in a market, and that was then the source of penicillin, which then was replicated many times over. But this paper showed that it's possible to have resistance to penicillin in vitro, even prior to that. But since then, every class of antibiotics that has ever been introduced, resistance has emerged within a few years of it, of that drug being introduced. And this is what resistance really looks like. You have a petri dish on the left side, you have bacteria growing, and these little discs contain antibiotics, different kinds of antibiotics. So effectively, if that antibiotic were effective, it would be killing the bacteria around it, as you see on the left side. But if you have drug resistance, then you see what happens on the right side, which is, in some cases, maybe a drug works, but not great. But many cases, the drug doesn't work at all. So the bacteria are happily thriving in the presence of the antibiotics. So, it's easy to see how resistance develops, and I'll see if the audio is working here. Otherwise, I'll use this. Let's see. So this is just to show you how resistance emerges. There we go.
So what we ended up building was basically a petri dish, except that it's 2 feet by 4 feet. And the way we set it up is that there are 9 bands, and at the base of each of these bands, we put a normal petri dish thick agar with different amounts of antibiotic. On the outside, there's no antibiotic. Just in from that, there's barely more than the E. coli can survive. Inside of that, there's 10 times as much, 100 times, and then finally the middle band has 1,000 times as much antibiotic. And then across the top of it, pour some thin agar that bacteria can move around in. The background is black because there's ink in it, and the bacteria appear as white. First, you see they spread in the area where there's no antibiotic, up until the point they can no longer survive. Then a mutant appears on the right. It's resistant to the antibiotic, it spreads, until it starts to compete with other mutants around it. When these mutants hit the next boundary, they too have to pause and develop new mutations to make it into 10 times as much antibiotic. And then you see the different mutants repeat this at 100. And after about 11 days, they finally make it into 1,000 times as much antibiotic as the wild type can survive. And so we can see by this process of accumulating successive mutations that bacteria, which are normally sensitive to an antibiotic, can evolve resistance to extremely high concentrations in a short period of time.
So, that's the scariest part of resistance, how quickly bacteria learn. And bacteria learn not because they're clever, they learn because of evolution, and this is evolution at work. It just took 11 days for it to be resistant to 1,000 the times the concentration of antibiotic that would have killed it off in the very first day. Now, this is what is happening in nature every day, all the time, when antibiotics are out there. We're doing the sequential selection for resistance, and there's no take-backs. Once you have taught them which mutations they need for survival, and they acquire compensatory mutations, then that information is out there in nature. They are out there in plasmids, these packets of genetic material that basically embody resistance. So think of it as we're creating a whole library out there for how to be resistant. And then after that, every new antibiotic that comes along has to deal with that library first, and then build on top of that. So it's, in many ways, if you think about it, 1942, first use of antibiotics, it's only about less than 80 years since we've had antibiotics, not that much at all. But as it happens, resistance has always been around, and the reason why resistance gets selected for is because fungal organisms have been fighting against bacteria for billions of years, for about 3.5, 4 billion years when all of these have been around. And so a small proportion of bacteria always have the information on how to be resistant. They have the mutations to be resistant. But what we do is we take that 1 in 100 million and we select those sequentially again and again and again over many years, and then that 1 in 100 million gets to 1 in 10 million, 1 in a million, 1 in 100,000, 1 in 10,000, 1 in 1,000, 1 in 100, and then now 1 in 2. So we've done that work. So resistance has always been talked about. It's been in the popular media. It's been written about a fair bit, covering all sorts of news outlets. Usually I put this up, but the students don't often know who Brad Pitt is, right? This is as old as it is, and all of these magazine covers are actually from the 1990s, believe it or not. But what happened in the 2000s was, even though we had some instances of resistance, it wasn't quite what it is today. So today, resistance went from, so the leftmost are 1999 to 2001, and the rightmost figures are from 2008 to 2010. Resistance went from, essentially under 2% to above 30% in just a short period of time. And that's just how nature works. You keep selecting, and then, it appears as if it's taking off exponentially from 0 to 30%, but that's not what's happening. It's been going that entire process, except we haven't observed it getting from 1 in 100 million to 1 in 100, and only now we are observing it and we think something extraordinary has happened. No, it's been happening all this time. In fact, if you see this, this is Acinetobacter resistance to carbapenems. When I first started working on it, which about 25 years ago, there was no carbapenem resistance recorded anywhere in the country. Nowhere. In fact, there wasn't. It was always seen as the backup drug. And that's what it was in 1999, very marginal levels of resistance. But as the data sort of kept accumulating, you get to 2005, resistance is above 40%, gets above 60%, and by the time this ends, most of the country is above 40 and often above 60%. Right? So that's remarkably quick. Think about it, that's just such a short period of time. And this is true in children. These are carbapenem-resistant Enterobacteriaceae. These are what the CDC director called nightmare bacteria. So when this report first came out, and the CDC put out a threats report, that's what spurred the Obama administration to very quickly, just within a space of 6 months, commit to a national action plan. And until then, the national spending on antibiotic resistance was probably $2 million. And today, it's about $1 billion. So it just ramped up that quickly. But thank God it did, because at least now we're making some progress against it. This is a truly global problem. It's not just here in the United States. In every country around the world, there's drug resistance. That carbapenem-resistant Enterobacteriaceae rates, you saw those rates are 5%, right? Now, we tried to do a study on this to look at kids with CREs and without CREs, newborns, in Kathmandu. We couldn't do that study because we couldn't find a single newborn without the CRE. So we couldn't do a comparative study at all to look at mortality outcomes. That's as bad as it is. It's 100% in some cases. This is the same bug, Enterobacteriaceae, and in Malawi. These are typically hospital-acquired infections, so you would not necessarily get them in the community from the person sitting next to you. But we never know. Methicillin-resistant staph, Staphylococcus aureus, very common bug, was that bug that killed that first guy, Albert Alexander, the policeman in Oxford. He had staph. And we always thought, staph is a hospital bug, you never get it out in the community. And then in 1995, the bug changed its mind. If it has a mind, it then started spreading in the community. So today, MRSA is more common in the community. You can get that from in the gym lock, or you can get that from someone close to you, particularly if you have a wound. And so you can't really predict how the bacteria will behave. And this is one of the challenges with even trying to predict what happens going forward. But if you notice the y-axis here, it's going from 0 or 20% resistance to 60%, 70% resistance in just a space of 15 years, which is just like that, right? And you see that across the board that resistance is going up. We see high patterns of resistance in every country for which we have data. These are a bit dated, but you see similar patterns. MRSA rates, Russia has high levels of resistance, so does Latin America. When you get to these gram-negative bugs and E. coli, so I'll tell you why E. coli is important in a few minutes, but extended spectrum beta-lactamase, these are some of the most challenging bacteria to deal with. E. coli. These are now highly resistant in India and China and most of Southeast Asia. Klebsiella, another very bad hospital infection causing bacteria, high rates of resistance in both Latin America and increasingly in the US, which didn't really have a Klebsiella problem 15 years ago, but today it does, as it has Acinetobacter as well. So we've now done a lot more digging. We have data from many countries, but wherever you look, you have high rates of resistance. E. coli, Pseudomonas, the same picture gets repeated over and over again, and the evidence is really mounting. So in fact, if you look over time, each of these lines represents just the fit to all the individual studies that were done to resistant, for ESBL carriage, extended spectrum beta-lactamase carriage. and every line is sloping up, but particularly in South Asia, which is emerging as a major hotspot of resistance. So how does the resistance really happen? Resistance is basically the bacteria is doing something that helps it evade the antibiotic. So when it's beta-lactamase producing, so when it's producing that beta-lactamase enzyme, what that enzyme is doing is essentially neutralizing the beta-lactam antibiotics, which is a very important class of antibiotics. It could build a thicker cell wall, it could just pump the antibiotic out of, using an efflux pump away from the critical parts inside the bacterial cell. So the bacteria does everything that it possibly can. And to do these, it really requires a mutation or a unique enzyme, for instance. Now, for this beta-lactamase production, in 1970, when we first started looking, there were really none. Today, they have over 1,000 of these enzymes. So think of this as what we have taught bacteria by sequentially using antibiotics in terms of how they know how to be resistant. So think of this as a key that they have to unlock antibiotics. They had no keys 50 years ago. Today, they have over 1,000 keys. So any new antibiotic will have to do better than all of these in order to really work. Now, newborns are at highest risk for drug resistance. Even without it being a drug-resistant infection, having a bacterial infection puts newborns, particularly in the developing world, at high risk. You don't see that many newborns with sepsis. It happens in this country, but doesn't happen quite that frequently. But it happens far more frequently in Africa, happens in South Asia as well. And when it's culture positive, then when the child has a positive culture, that itself is a 1 in 3 chance of dying. But when it's ESBL producing or MRSA, which is to the right, then you're talking about a 50% chance of dying. Now, nobody wants a greater than 50% chance of dying for a newborn. But that's the situation you have when they have these drug-resistant infections, because they're often in places where you don't have effective antibiotics as well. Now, that was one study in Tanzania. This was then replicated with a bigger study with 80,000 children in New Delhi. And again, you see high rates of mortality, 60, 69, 61, 62% chance of dying with resistant pathogens. So newborns are really in the front line of being targeted by drug-resistant pathogens and being consequential for them because they are at high risk of dying. And we've compared this across multiple other studies from multiple other countries, and you find very high rates, case fatality rates for newborns. Now, if you look at the causes of deadly multi-drug resistant infections in India, for instance, it's all over the place. It's a lot of Klebsiellas, Pseudomonas. These are what are called gram-negative infections, and it just means that they are not stained by a gram stain, so it's a capital G. But the important thing is that this also happens to be the category of bacteria for which we have the least antibiotics. In some cases, no antibiotics. CBS 60 Minutes did a story recently on various things, including India, but also on this patient at Mass General, who literally was his infection was untreatable with any antibiotic except for one, and they were just worried that if that one failed, he was pretty much done for. A woman in Arizona last year, she died after being she had an infection that was that was resistant to 27 antibiotics. At UPenn. I usually check in to see how they're doing year by year. About 15 years ago, they would have had no patients for whom they could do nothing for. Today, they would say that there are about 50 to 100 patients a year for whom they can do nothing. There's no antibiotic they have. They just have to put them in the ICU and just hope that something's going to get better. Because when you get the antibiogram for that patient, you see R, which means everything is resistant. So it's scary when you get one of those and you just see everything is R. Nothing works. If you look at mortality odds in patients with resistant bacteria, this is not just children or everyone. You can just see the pictures. It's much higher both in patients, particularly if it's multi-drug resistant and also extensively drug resistant. So that's 2.5, 3 times odds compared to if that person were drug sensitive. So I don't know about you, having a 2 to 3 odds chance of dying because of something that you had no control over, it seems like a tough situation. And that's what makes these different from any other drugs, right? Arthritis medications work as well today for everyone as the day they were first introduced into medicine. Statins work exactly the same way today as they did when they were introduced into medicine. Not so for antibiotics, because antibiotics are really a shared resource. Where if I overuse antibiotics, it affects all of you, right? In that sense, we're sharing this resource, and if one of us screws it up, then it has consequences for everyone else. So we did compute how many newborns were dying because of drug-resistant infections every year. And this was, the number was over 200,000 newborns every year, and this was a very conservative estimate. But even so, it was a large enough estimate that it was front-page news in the New York Times when that study came out. And it was essentially this combination, which is, this was based on a study done in India. And superbugs do kill India's babies and do pose an overseas threat. Now, the other population that's at risk is the elderly population. And the elderly population, for now, but all of us, because we'll all be in a situation where we're going to need one of these procedures. What modern medicine is, if you really think about it, is the ability to have access to these procedures, whether it's spinal surgery, it's hip replacements, it's C-sections. That's what we think of as medicine, right? So before you suffered without these, but you have these. But for all of them, antibiotics are important because they help prevent infections. And the absolute risk reduction associated with having an effective antibiotic is non-trivial, particularly for colorectal surgeries, but for pretty much everything else. So we've done surveys of studies going back, back to the 80s, and take colorectal surgery particularly. There used to be 10%, an infection probability was 10% back in 1980. These are all US data, by the way. And that probability is now 25%. And it's not necessarily that the infection is what's going to make your health worse off. If you as a patient had to make a determination on whether to get that hip replacement, knowing what the odds are for infection, you might just choose not to get that hip replacement. So in that sense, it's a much more profound effect than just the direct medical cost of infections. If we choose to forego what we would consider modern medicine because of the risk of infection, that's in a sense giving up a huge amount of value, because that's really what we, that's what we count on to sort of keep us healthy. And we did this study, so most of these studies, by the way, were done here. So this was done by a student here a few years ago, who's now in med school in France. And so the total estimated infections was about 120,000 infections, about 6,000 deaths associated with having decreased efficacy of antibiotic prophylaxis. Now remember I told you E. coli. E. coli is important because it's the single most important reason for having urinary tract infections. Now, at a younger age, women are far more likely to have UTIs, but as you get into the 60s, men and women, the risks converge for having urinary tract infections. And UTIs were never a problem. You took Bactrim, you took a course of it, and you got better. And this was a series, I'd highly recommend you read this particular series, Deadly Germs, Lost Cures, a set of 5 long-form articles that I know the New York Times is aiming for a Pulitzer with this particular series. They've timed it that way. But this is a 5-part series which is really on various aspects of drug resistance affecting the United States and globally, but particularly here. One was Candida auris, this fungal infection that was highly drug resistant. But this one was truly scary because, I often see patients who have particular kinds of infection, but I have not personally met advocates, women who have UTIs that were never curable, and they've suffered with these for months, if not years. And this is again a problem across the world. And the right side is from the Times of India, which again is UTIs turning deadly. No one should be dying of UTIs, but that's happening, and that's happening increasingly around the world. So, this is a slightly detailed picture, but basically we find that in the best hospitals anywhere in the world, having these E. coli infections, multi-drug resistant E. coli infections, was associated with a 2 to 3 times higher mortality. And mortality due to MRSA is also higher, particularly when they're resistant to this class of antibiotics called aminoglycosides. So the evidence is really mounting on this. Gonococcal infection. So gonorrhea, fortunately not deadly, but challenging for many reasons. And we really didn't have that many drugs for gonorrhea before, but now we're back to the same situation, 0 to 0. So today there is no drug that reliably works for gonorrhea. Truly no drug that reliably works for gonorrhea. And that's the same situation as it was before. I actually, when this first came out, I did mention, I said 80s were when we had the most most drugs for gonorrhea, and a reporter picked that up and he said the headline was 80s the best time to have gonorrhea. Which is not what I said. I don't think it's any good time to have gonorrhea, but one had to choose the 80s would have been a good time. So we missed the boat. So gonorrhea infections are getting worse. So resistance to ciprofloxacin, again a drug you wouldn't have used for gonorrhea 20 years ago. Cipro is a more powerful drug. And the interesting thing about gonorrhea is that the history of it is really interesting. Gonorrhea used to be completely susceptible to penicillin, and that was all the way through to the Vietnam War, when they handed out a lot of penicillin in the brothels in Saigon, basically to prevent US soldiers from getting gonorrhea. But by the time they left, it was almost 100% resistant. And that particular strain came back to the US and effectively came through the Philippines and then to the US, into Seattle as a matter of fact. And since then, penicillin has never really worked. But that just goes to show that what happens in one place has consequences everywhere else. This particular bug, New Delhi metallobeta lactamase, was identified in a patient from New Delhi, was in Sweden, and very quickly is spread. Now, this is a particularly problematic resistance gene because it confers resistance to carbapenems. I told you that wonder drug that worked for everyone. Now NDM is everywhere. 1 in 2 hospitals in the US has NDM. And it just took just a few years for that to happen. So they don't carry passports, as you know, but they travel really quickly, and they travel as quickly as people can get from one place to the other. MCR1, so if one did have carbapenem resistance, then the last resort drug is a drug so lethal that even just taking the drug is highly nephro and neurotoxic. In fact, in some countries, and in Vietnam, until very recently, it was not even approved for use in humans. So if a patient had multi-drug resistance, they would send someone to the veterinary sector to go get the drug because it was only allowed for pigs, and they would give it to the humans because it was such a toxic drug. Today, colistin doesn't work, and the fact that such a bad drug doesn't work is itself, that's sort of a real tragedy here. And colistin resistance is again all around the world. It's certainly in the US, but it's in many countries, any country that is actually looked. Now moving on, what do we use antibiotics for? In this country, and this is infectious disease mortality in the United States, in the previous, this works. But this is infectious disease mortality in the United States back in, there you go, in the previous century. See, it went down from quite a bit, 800 per 100,000, almost 75% before penicillin was ever introduced. So the main reason why infectious disease went down in this country had nothing to do with vaccines or antibiotics. It all had to do with public health, hygiene, sanitation, chlorination, and so forth. Now, so it's gone down obviously further from there, but in South Asia today, crude infectious disease mortality is twice what it was in the United States in 1942. And in sub-Saharan Africa is almost 3 times as much, which means that antibiotics are not used after reducing infections through water and sanitation and hygiene. They're used instead of water, sanitation, and hygiene. So when you use it that way, it's a bit like mopping up the floor when the tap is still running. There's not enough that you can throw at it to really stop. So the first thing that one really needs to do is really to improve water, sanitation, and hygiene. The other thing that you can do is improve vaccination. So until 2000, actually until 5 years ago, the one category of patients that got the most antibiotics in the US were children under the age of 5, and it's primarily because of ear infections. So those of you who had kids prior to 2000 would remember ear infections. Today, ear infections are just not a thing anymore. Well, not very much at all because of vaccines. The introduction of the pneumococcal vaccine really reduced the prevalence of pneumococcal pneumonia and all of the associated disease. And it went down both for susceptible and resistant disease. And antibiotic prescriptions also went down. So otitis media's ear infections decreased almost 42% because of the introduction of the vaccine. So if we could do that around the world, many countries have already introduced this vaccine. China is the only large country that has not yet introduced the vaccine. But that would again make sure that if we can prevent the infection, then we reduce the need for antibiotics. Of course, then we have to reduce the use of antibiotics as well. Even in this country, something like between 30 to 50% of antibiotics that are used are deemed unnecessary. And the US is one of the largest, highest per capita consumers of antibiotics. Now, it's not uniform across the country. The average person in California or Alaska consumes half the antibiotics as someone in Tennessee or West Virginia. So huge variation across the country itself. But the US does consume a lot of antibiotics. So we've looked at that in numerous studies. And so global consumption of antibiotics between 2000 and 2015 went up almost 60%. Most of it was just in the developing world. So if it's blue, it means that it's kind of flattened out. And much of that flattening out is really because of that vaccine being introduced, Prevnar. And for the rest of the world, it's actually going up. It's going up in China, India, Brazil, all over the place. And that's some cases it's a good thing. So you have poor countries that are consuming more antibiotics per capita because now they have access to antibiotics. Now, in spite of drug resistance being such a big issue, more people die globally because of lack of access to antibiotics than do because of drug resistance. Now, that will change. It will surely change in the next 10 to 15 years. But for now, it's a lot of kids dying in poor countries because they didn't have access to penicillin. It's truly ironical, right? So many of these kids, it will be like the first time they ever get an antibiotic. Anyone in their family ever gets an antibiotic, and it won't work for them. Not because they had anything to do with it, it's because other people screwed it up before they ever got their hands on it. So you do see this convergence globally, and when we've projected these forward, you can see that we're going to see a lot more antibiotic consumption. So if we think we have a big problem today, we've not seen anything yet based on what's about to happen in terms of increases in consumption. If we're able to stop it, then it'll only grow by 50%, but the most likely scenario is probably going to double in the next 10, 12 years or so. Now, India is the largest consumer of antibiotics, and China is number 2 in humans. But you have to remember that human consumption only accounts for 1/3 of all antibiotic consumption. Most of it is in animals, which we'll get to in a second. But in humans, naturally, these countries have large populations. As you know, India doesn't like to lose to Pakistan on anything, but definitely loses on carbapenem consumption. But this is going up, quite a bit. It's going up in Europe as well. Strangely, because when you perceive that the old drug doesn't work, and even if there's like a 1 in 5 chance that the old drug doesn't work, the doctor doesn't want to give you what they perceive to be a drug that has a 20% chance of failure. So they move everyone over to the new drug, which is then sometimes a problem. A lot of people get antibiotics without a prescription. Now that sounds terrible, but it's not as easy to solve as one might think, because in many places there are no doctors. I mean, there are mostly quacks. People are not really trained medical providers. And so if you relied on a reliable doctor giving you an antibiotic, then you're out of luck in many places. In the US, there's approximately 1 doctor for every 500 patients. In China and India, these are averages. Most of those doctors are actually in urban areas. Parts of, rural Kenya, rural India, there's 1 doctor for every 30,000 patients. 1 for every 30,000. If you had to wait to see a doctor before you got an antibiotic, your child would certainly die. So we'd like to see more prescription-based antibiotic use, but before that, we'd like to see more doctors. Now, one of the main reasons why antibiotic consumption goes up a lot in December, so this is peak month of consumption. So reds are in January, peak month of consumption, and the greens are peak month of consumption is July. And globally, the flu season drives a lot of antibiotic consumption because people have the same symptoms, they have a fever, and then they go demand an antibiotic. Because there's this great perception everywhere that antibiotics are completely safe. It just doesn't, people don't realize that antibiotics actually are drugs with serious side effects. People have, allergies to antibiotics. If you take an antibiotic yourself, your chance of a drug-resistant infection is vastly greater, at least for the next 6 to 8 months. So it isn't as if one should take an antibiotic for no reason. So this is, again, when we looked at influenza data, and we tried to predict influenza in the US using using antibiotic consumption data, we could do an almost perfect fit, which is scary. If we had flu data, we can tell you exactly how much influenza there is. And this is a correlation that just should not exist. Now, consumption of antibiotics is highly correlated with resistance because you're selecting constantly in the way that you saw in that petri dish. And this was the first study that was done in Europe, which has each of these data points as a country. That's consumption on this axis and resistance on that axis, so consumption predicts resistance. And we saw that very neatly here. So it was always thought, well, consumption perfectly predicts resistance. This was actually the senior thesis of a student that was done here at Princeton, who's now finished med school. And in this work, and this was published in the Clinical Infectious Disease, a very good journal. So she was looking at seasonality of prescriptions and then of resistance as well. And very nice piece of work showing just a 2-month lag between prescriptions and resistance in this work. And similar work has been published on seasonality, prescriptions, and resistance. So this is received wisdom in the developed world that if you prescribe more, you're going to have more resistance. And you can also check it by saying seasonality prescription is not associated with viruses. So it's a purely bacterial phenomenon. Now, the other point that I made earlier, which is there's still a lot of kids who are dying because of lack of access to antibiotics. So pneumococcal pneumonia still kills a lot of kids. So when it's higher reds, then the rates are higher. But you have to remember that even if the rates are lower in places like India and China, the populations are so large that you have a large number of children. But the tragedy is that penicillin is not widely available. Now, penicillin works in some of these cases. In fact, this was a very recent study that penicillin works. Penicillin is not uniformly useless. It does work in many instances, including for this. But penicillin costs 20 cents. In fact, if you went to the local CVS and tried to get penicillin after going to the CVS Minute Clinic, your copay will be higher than the cost of the penicillin. I think the cost is 20 cents and they'll make you pay 50 cents for whatever reason. So but it's so cheap, no one has an incentive to go and produce it. So bacteria are everywhere. So you often hear of people saying, "Oh, I don't want to touch any bacteria," which is kind of stupid because it's like fish saying, "I don't want to touch water." Right? We all live in bacteria. The bacteria on every surface, in the space between us, and they're moving all over the place. So they're moving from humans to animals, and we transmit bacteria to animals, and they transmit bacteria back to us, particularly to companion animals, but also to other animals. We try to look at what predicted resistance around the world, and what we found was that consumption was not necessarily the biggest driver, but what we found was that education, infrastructure, health expenditures, governance, these really predicted resistance, simply because if you are able to prevent transmission of infections, you do a lot better with respect to resistance. I don't worry as much about resistance in this country, except if you're in the critical age groups, in the scale that you'd worry about in India or Vietnam or China, because their transmission of resistance is so easy that resistance emerging in one place is everywhere in no time. So that's where the biggest threats really are. But like I said, resistance does move around a fair bit, and one of the places where it's generated a lot is really in animals. So 2/3 of the tons of antibiotics sold worldwide are used in agriculture. Why is that? It's a great innovation that started right here in the 50s when it was discovered. It even made the front page of the New York Times. Wonder drug aureomycin, Oreo because it was golden in color, was found to spur growth in chickens 15%. And industrialized agriculture has never looked back. So literally the whole factory farming business was made possible by antibiotics. Just could not have happened. There's no way you can stuff tens of thousands of millions of chickens into a confined space without antibiotics. It's just not possible, because they either get infections, or you're not feeding them enough, or whatever it is, and they will die, or there will be mass outbreaks. But as infection control, as nutrition, all of these get better, then the value of antibiotics actually goes down. So these are studies done in the 50s on the percentage improvement in average daily growth of pigs fed antibiotics over time. And that's about 8 or 10%. You might think 8 or 10%, that's not a lot. For a farmer, that's a lot. But over time, that benefit has really come down significantly. Why? Because if you go into these farms, they are modern facilities. You have to go in a moon suit because, not the animals, because you really have to they have to make sure that you're not taking in infections into the animals. Everything is highly mechanized, temperature controlled, and the chickens, they don't get fed 3 times a day anymore. They get fed whenever they want to. It's like a little buffet thing. They can tap their little beaks and get water. There's constant food available for them. They have little exercise, I mean, I'm not making this up, they actually have space, so they can even go out, in fact. But chickens don't like to go out because they're small flightless birds, and they usually are, they are chicken, right? That's true. Called chicken for a reason. So this is where we're at, which is why 15 years ago you could not imagine that Purdue would have billboards saying no antibiotics in our meat, period. They could have just never done that because they didn't have the biosafety, the biosecurity to make that happen. Today it happens. I've been on these farms, they're truly amazing. But still, it's a small proportion of the total poultry consumption. I'll tell you a little thing. Actually, that shift happened because of a very, many people don't know about a rule that the Obama administration passed in 2016. They basically, very quietly, adopted a pro-antibiotic effectiveness stance in all federal purchasing. So they basically said that if you have identical products and prices, if you've raised without antibiotics, you get first preference and first in line. So think of all the federal cafeterias, every place that has federal money, all now, they saw this as a competitive advantage. So this is really the reason why things changed a lot here. And of course, consumers then heard about antibiotic-free meat, and then consumers thought, wait a minute, I didn't know it had antibiotics in the first place, so now you're telling me it's antibiotic-free meat. Of course I want the antibiotic-free meat. But not so in other countries just yet. China, India, poultry production is set to increase 2 to 7-fold because people want to eat meat, and people in these countries don't eat that much meat right now. Not because they don't want to, because they'd like to, but they can't afford to. But that's changing. In fact, in China, total pork consumption has gone up 6-fold between 1975 and 2014, 6-fold. That's a lot of pigs. I mean, there's 6 times the number of pigs in China as there are in the United States. And if you had to look for one species that consumes most of the world's antibiotics, it is pigs in China. Pigs in China consume most of the world's antibiotics. And in fact, that big circle there shows that most of the world's antibiotic consumption in animals can all fit into how much China consumes here. So global consumption in food animals also estimated 131,000 tons, projected to go up to 200,000 tons by 2030. This is all like rising really fast. We've published on what might be possible. You can have no intervention, you can cap the total amount of antibiotics in animals, you can have meat reduction. So when we said meat reduction, we didn't mean that people had to become vegetarian. We just said, well, don't eat meat 7 days a week. Eat it maybe 4 days a week. And of course, that was not very popular with the media. And then you can tax, you can have meat reductions and combinations and so forth. But in many ways, you're dealing with something very similar to climate change, and that's the thread that'll run through. This is like climate change. This is global, can only be addressed globally, and has consequences that affect really everyone. We've looked at what it costs to actually reduce antibiotics in animals. It's really not that much. It's $1.34 for reducing antibiotic consumption in pigs. And and it's possible. Like Purdue now says no antibiotics ever. Now, one thing is that when they do have to treat some animals with antibiotics, you know what they do? They treat them with antibiotics and sell them off to a different brand, to a different company. So they're actually truthful that the meat that they sell doesn't have antibiotics, but it's not like they don't use antibiotics ever. That's actually some of us in moon suits going to visit these farms. And finally, what's happening to all these antibiotics? They're out going into the effluent, they go into the river basins in China, all over the place, and they result in resistance. So if you look at Chinese swine farms, they are like highly developed biothreat labs, because they're essentially generating every kind of resistance that you could possibly think of and really enriching these. So they're pretty dangerous places to go to. If you get an infection on a Chinese swine farm, you're truly out of luck in terms of getting treated. This was a study that was done by a Princeton undergrad who then spent 2 years on a Fulbright in India. And he did this very big study looking at drug resistance in chickens in India. Not as high as in China, but still pretty scary. This study actually just came out 2 days ago, and this was from a former postdoc here, showing that, it's a new slide, so I got a typo there. Resistance has increased nearly 3-fold in food animals between 2000 and 2015. So everyone's worried about resistance in humans. What about poor animals? And we looked at animals, and we compiled 901 point prevalence studies, and this is what we found, that animals were at higher risk for infection that couldn't be treated. And so I'll skip this bit, it's small, but just to say that the red spots are all indicating where resistance is already high, and the bottommost picture shows you where it's about to get even higher. So I'll send you the paper if you're interested. Now, pharmaceutical production also causes antibiotics to go into the environment. In fact, there are very high concentrations of ciprofloxacin in these plants, which are, putting the effluent out into the water. In fact, higher than what you would find in a patient's bloodstream. And many, many companies around the world, particularly the generics, just don't do enough to really stop this use. And finally, it's in the environment. So this is mass bathing events that have been studied in India. And this NDM1 is about 20 times greater in the Ganges during the pilgrimage season than at other times in the year. So you go in, and this is where you're going to get your dose of drug-resistant bacteria. I'm not saying you avoid these in all cases. Now, most people are not necessarily at risk for them. But if you have a cut, a wound, some reason why you got an infection, then this becomes a real problem. So this was just that study that indicated this. And this is from the Netherlands, showing that you look at soil samples and resistance genes have been going up over time, starting from the 1940s. So last few slides are to say that, look, this is really a problem just like natural resources. You can make better use of existing drugs. You can find new antibiotics. New antibiotics are far more expensive than existing antibiotics, far more expensive. So all the ones on the top are what the rich people use in developed countries, and this is what the poor use. And at the end of the day, we've got to be prepared for the fact that many of these folks just won't be able to afford the antibiotics that they would eventually need. The production of antibiotics, the new development has really slowed down over time. We've had, most of the antibiotics that we have now were discovered prior to 1960. In fact, the last antibiotic discovered for gram-negative organisms, the stuff I showed you right at the beginning, the last antibiotic for that category, the last new antibiotic, class of antibiotics, was over 50 years ago. Over 50 years ago. We've had nothing in that period of time. But we're hopeful. There's a lot more going on in the space. There's now, after a growing lag, we have new drugs, but prices are likely to be high. And I'm just going to skip this to say, all of these, which are not solid colors, basically means these are knockoffs of existing antibiotics. No real new development there. These are all Me-Too drugs that are coming into place. So just wanted to close by saying, look, this was what the pre-antibiotic era looked like. So this poor man, he's exercising on a plot of grass somewhere near, in Georgia, near Athens, Georgia, and the cut doesn't heal as quickly as it should, and he finally has to go through an amputation. Doesn't happen that frequently now, but it's happening more and more often. It's something which you hear about. 25 years ago, I didn't actually know patients who had drug-resistant infections or people who died. Today, I see that all the time. It's all too common. And it's like HIV. No one actually died of HIV in the early era. Everyone died of something else, and that's what this is like now. A lot like climate change, as we've already discussed. And just to say that, the future we've got to be ready for is the fact that these are antibiotics, the newer ones. They don't cost more than a couple of $100s. The newest cancer drugs cost $31,000 to keep you alive for 3 extra months. Now, would you be willing to pay $31,000 for an antibiotic that effectively, cured your infection and kept you alive till your natural lifespan? You might, but are you ready for a world in which you're ready to pay $31,000 for an antibiotic when you pay $5 now? And that's really the situation. Earlier this week, I was at the UN General Assembly. This is the 3rd anniversary of so if you see, read the print out there. It was a high-level meeting 3 years ago on antibiotic resistance. Only the 4th time that the General Assembly has actually taken on a health topic. It was a huge deal. And there was a declaration that came out of it. A lot of progress in the last 4 years, particularly in the United States, but in many other countries as well. And I think, it's certainly in the public's consciousness. A lot more can be done. We work in many of these countries to get their policies up to speed. But we're not quite there yet, and this is one of these problems that's just not going away. As long as the bacteria can evolve, they're always going to learn how to be resistant to the antibiotics. And we just have to keep a step ahead of them and figure out how to not use antibiotics when they're not really needed. So the slides are all here and the data are out here. Thank you very much.
questions. If people have them, can you put your hands up and we'll get a few gathered together to pitch to Ramana. Well, there's 3 in a row in front, please.
It seems to me that it's easier to find antibiotic-free poultry at the supermarket than red meat. Is there a reason for that?
There's not as much use in cattle as there is in poultry on a per pound basis. It's also the most intensive place, but I'm surprised there is now antibiotic-free cattle as well. Maybe you just have to ask for it, but it certainly exists. Certainly exists. Antibiotic-free pork as well.
With respect to the fascinating data about flu and the use of antibiotics, has that curve begun to dip a little now that there are some antiviral treatments for influenza if you get it early?
It still doesn't change people's perceptions of flu symptoms being something that they want an antibiotic for. So people are not really getting, flu medication as in treatments as often. The flu potentially could come down if you have an effective vaccine and the coverage goes up. But for everyone else who gets the flu, they have body aches, they go to the doctor, and the doctor gives them an antibiotic. In this country, often because they're trying to make sure that you don't get a secondary bacterial infection, of which the probability is extremely small, but they just don't want you to get that secondary bacterial infection. So it's a lot of defensive medicine happening here as well.
Okay, thanks so much. It's fascinating. So many dimensions involved and so comprehensive. The first question I have, if you can tell us a little bit more about the US story, right? So because that variation, you said in some places, that much consumption or prescription, how does the medical community participate in this process of creating this culture of consumption, and where do you see entry points within medical practice and regulation itself? But then the second question has to do with where you ended, right? So you seem to suggest there are ways in which policy can intervene, at the national level, like the Obama administration, et cetera, right? So how do you think this call for intervention can be taken up at a global level in a more strong, more robust way than it has been? You mentioned the UN, etc. But what about the players? What about the big players in global health? Be it philanthropic organization, scientific laboratories, governments, World Health Organization. Where do you see something gelling, and where would you like it to go?
So I'll answer the second part first. All of these organizations are very much on board. And Obama was not the only leader to talk about it. This has been featured in 2 or 3 G7 meetings. The Germans are very articulate on it. Helps that Angela Merkel is a scientist herself. She's chaired meetings on AMR herself, just with a group of the small, because they bring a lot of thought to the process. This was a big issue in the UK. So I think the global leadership is very much involved. There's always the usual whining about lack of money and all of that stuff. But we are certainly in a far different place than where we were 3 years ago, no question about it, on all fronts. The first part is to do with the behavioral aspect. I in fact usually have a whole section where I just took that out because it's, that's a lot. But as you realize, as you know well, physicians are very central in this entire process. Physicians don't always act as good stewards for antibiotics because if you ask a physician, is antibiotic resistance a problem? They'll all say, yes, it's a big problem. And you say, now who's causing the problem? They'll say, oh, all those other doctors, they're over-prescribing antibiotics. Say, what about you? What about your prescription of antibiotics? Say, oh, my patients are pretty sick, so I'm very careful about how I use them, but they get exactly what they deserve. Which is, everyone's watching out for their own patients because that's what they're really focused on. So in that sense, it is a commons issue. You're sort of, you're acting selfishly in that sense. And there are lots of behavioral dimensions on this. So, for instance, you know what the single biggest predictor of antibiotic consumption in a county of the United States? It's simply the number of physicians practicing in that county of the United States. If there's more, and this is not true just for the US, there's the same study in Taiwan as well. If you have more competition, you hand out more antibiotics. Right? I don't know if you remember, for a while there were grocery chains that would give you free antibiotics as a loss leader to come into the grocery chain until that was stopped. And that's because, again, of this perception that these are extremely safe drugs. They are not. for some strange reason, people think that vaccines are unsafe and antibiotics are safe. Not true at all. Right? Vaccines are pretty safe, and antibiotics have some serious side effects. I'm not saying, that we should not use antibiotics, but we should be mindful of the fact that they have consequences. But, in this very same room, about 3 months ago, we called in a lot of physicians, pediatricians from the area, as part of a project to answer exactly this question that you're asking. And we really should have had you. We'll have you at the next one. And we asked them why they behave the way that they do, and they had a very interesting set of answers related to, of course, there's a whole bigger story about breakdown of trust in doctors, in science, which is part of the story as well. Everyone goes to Dr. Google first, gets a consultation there, and then by the time they show up at the doctor, they know what they want.
Yeah.
So that's very different from how medicine was 30 years ago.
More questions?
Can you talk a little bit about the potential around alternative technologies for fighting bacterial infections, both in the human medicine, the agricultural setting, particularly around phages and kind of the outlook for.
So I'll go over that quickly. So bacteriophages are basically viruses that kill bacteria. There is anecdotal evidence that these work, and this, the former Soviet Union had a huge program on bacteriophages. It all collapsed when the Soviet Union collapsed. In fact, the only couple of phage therapies we have in this country were by Russian scientists who then emigrated here, and then we have that information. Recently, actually, a senior medical scientist at USC, is a good friend. Her husband, who was on the verge of dying, basically got this phage therapy. He survived, and she's written books about it. She's on all the talk shows, and everyone thinks it's going to work. But as the FDA will say, that's a sample size of 1. You don't get to clear drugs with sample size of 1. And there are challenges with it. You're really using one organism to kill another organism. So how carefully can you do that? Probiotics, a lot of promise, but not enough evidence here again. We certainly know there's a lot of microbiome issues related to antibiotic resistance, but we don't completely understand this very well. Quorum sensing, of course, Bonnie Baslow is here as the queen of quorum sensing. She can talk much more about this. You should listen to her TED Talk. And quorum sensing is effectively this way of disrupting chemical signaling between bacteria, which then prevents them from attacking. But then we've not seen that really translated into therapies. It's hard to do. And symbiotics similarly, which are new age technology. There are many more as well, but these are not quite at the place. I mean, monoclonal antibodies, again, which can be used either as vaccines or as treatment, not on this list, but probably much further along. We have alternatives, and in fact, if we made the progress in science that we really should, we should not even rely on antibiotics 30 years from now. We should just have something completely different, right? But we just can't see what that is yet, and maybe it's hard to see that unless we're just on the verge of it. I mean, the day before Alexander Fleming discovered penicillin, we would have thought, how are we going to deal with bacterial infections? Right? So we're in that place of looking and for answers. But one of the things is there is a lot more money on antibiotics and new drug development and so forth today. Not nearly enough. It's a terrible business to be in. It's a losing game, but at least it's progress from where we were.
So you talked a bit about the trend of using antibiotics in chickens and then turning away from antibiotics. Is there a similar trend in pigs and cattle farming, or is that is the use different?
Less so than with poultry. That was a question up front as well. But it's happening. I mean, it's happened in Europe, obviously, where all medically important antibiotics have been phased out. In the United States, something remarkable happened. Because of all of this, in 2013, the FDA basically said, before that, you could literally buy like a 30-pound bag of antibiotics, of Cipro. You could buy a 30-pound bag for $70 from any sort of farm store. But if you went to McCosh to get the same, in 10 tablets, it would cost you $70 for those 10 tablets. Of course, and same grade, medical grade, but the fat bag. The FDA basically said you can't do that anymore. If you're going to do that, if you're going to put it into the food and water, you have to have a veterinarian really sign off on every use of it. So So that applied across the board. That was not just for poultry, that's for cattle, that's for everything. That made a huge difference. In fact, medically important antibiotics, the consumption in the US just it's really started coming down in the last couple of years. And that's across the board, that's cattle. But it's one more step to just make it completely antibiotic free. We're within reach of it. In fact, organic chicken is far more expensive than antibiotic free chicken. Because for organic chicken, you've got to raise the entire grain. And if you look at a chicken from the farmer's perspective, most of that chicken cost is really food. It's the grain that makes the chicken. And to make all of that organic is pretty expensive. This stuff can be done.
Why is it that the discovery of new antibiotics has slowed down so much and is so difficult now as opposed to 50 years ago?
Great question. So there's about 3 reasons. One is we may have found all the easy ones first. The second is the cost of regulation, getting a drug to market, is across the board much more expensive today than it was before, regardless of category of drug. The earliest antibiotics didn't go through clinical trials. I mean, penicillin didn't ever go through a clinical trial, right? Because this was the era before clinical trials. And the third reason is that it's a bit of a numbers game. So there's 7 billion people on the planet, there's probably 7 billion bacterial infections. The proportion that will actually die of a drug-resistant infection is probably 0.01%. But 0.01% of that large number is still a very large number. So for a new company to come out with an antibiotic and to be able to sell it to that person who's going to die of a bacterial infection, they'll have to sell it at least $5,000 or $10,000 to make the money back. It's very hard to find that pathway. So there are companies with approved antibiotics that have collapsed in the last few months and years because they can't sustain that business model. So the only way out is to have public funding, which is now happening for antibiotics. And it's happening in Europe and here in the US. Because otherwise we won't reliably have antibiotics all the time. I mean, sure, when things get really bad, drug companies will come up with the new antibiotics. But you know what, they'll be super expensive and they'll be misused.
I was wondering if you saw a role for more accurate and cheaper as well as more accessible diagnosis test kits in pinpointing the therapies that doctors use. So I had an experience last flu season where a family member of mine was very sick and called the doctor. The doctor said, no, it's flu, just don't come in, supportive care, stay hydrated. But it actually turned out to be strep. And so there was, he was trying to do the right thing, the doctor, and not prescribe an antibiotic, but in fact, if the proper diagnosis had been there, then it could have more accurately pinpointed.
Great point. So we did this study, which I took the slides out on it. In the US, the good news is that, so we did the study in 6 of the best hospitals in the US. 60% of the time patients got a culture when they got an antibiotic. Good news. Bad news, 40% did not. When the culture result was negative, again, in about 60% of the time, they did not take them off the antibiotics, right? So it's not just a question of having the technology to know what's happening with the patient, it's the willingness to also respond to do the right thing after that. One of the big things that's and this can work in all sorts of perverse ways. I mean, I think of diagnostics as being a purchase of information. But what you do with that information is then also a behavioral question, right? And then you might act in different ways. In Africa, the introduction of diagnostics for malaria has massively increased the consumption of antibiotics. Why? Because now they do the testing and they find, oh, it's not malaria, so but we have to do something for the patient, give them an antibiotic. So it has these sort of unintended consequences as well. But without question, we need to do better on diagnostics. But diagnostics are both about the technology and behavior as well.
Okay, one more question there, please.
So, looking forward more to a solution, what do you feel most optimistic about in terms of policy, which would require getting many different nations to agree on their antibiotic therapies, finding new antibiotics, which is a long-term problem, or as you mentioned with the pages, or those, you mentioned something with antibiotics which sounded interesting, but these are all still pretty experimental technologies and not yet marketable. So where do you have the most optimism in finding a viable solution?
So I think there are many avenues for this. So certainly work in animals, you can reduce consumption in animals, you can improve water and sand. I mean, there's a whole bucket list there. I think the fundamental problem that we have is that people don't understand antibiotics. They take them for granted. And if I was giving this talk 30 years ago, half of you would be smoking and probably I'd be smoking as well. But you don't see that today. And that's because there's a social norm shift which says you don't smoke. You probably get in trouble with the university as well, but even before that, there's a norm. And that norm doesn't exist for antibiotics. In this country, in Sweden, the average Swede consumes half the antibiotics that the average American does. The average Swede is not sicker than the average American. Now, the average Swede does that because the norm there is you never go to a doctor and ask for antibiotics. The norm there is that the doctor always says, wait for 3 days and then I'll give you an antibiotic if you really need it. And people are totally fine with it. Here I don't know if you've ever been to a pediatrician's practice, but you will hear people screaming for an antibiotic, right? So it's very, very different in terms of what people's expectations are. I think that is the most fundamental thing. If we can get people to change, I mean, it's kind of hard because climate change, as difficult as it is, it's kind of out there. It's in the weather. It's in polar bears. This is in the bacterial world. No one gets to observe what's actually going on there, and therefore people's sort of connection to the problem becomes a little more challenging on an ongoing basis. And I think you asked a question about what needs to happen. I think the fundamental thing that needs to happen is this better understanding of this bacterial world, our connection to it. Most of what screwed us up in the last 50 years was we always had this idea on the war on bacteria, the war on infectious diseases. That's not a good metaphor because we're never going to beat the bacteria. They've been around for 3.5 billion years before us, and there'll be a 3.5 billion years after us as well. So that's the fundamental thing that needs to change, but it's hard when it's a whole mindset shift that's really needed. But if we have that going, then you can get the politicians, everyone on board. It's about relation to science, it's about trust in science. These are all at the bottom of it. The technical solutions, I'm sure, will happen because science progresses quite well on its own, and when there's a problem, people will seek out a solution.
As a follow-up to that, what are the prospects for international coordination? Because it sounds like good ideas are popping up and being applied. But given that, as you said, bacteria cross international boundaries, the people across international boundaries need to adopt good practices too. What are the prospects for that, for getting at the big industrial agriculture in China, for example, coordinating globally?
It's starting to happen. So the Germans have set up a global AMR R&D hub, which is now coordinating a lot of research on AMR. So I chair the board of an entity that was set up by the World Health Organization, which is really a late-stage funder into new antibiotics. So we look for companies on the verge of dying and then pick up their drugs and help them to the finish line and make those drugs accessible. So for gonorrhea, for instance, is a new drug that will come out in the next 2 years, which is effectively in that place. There's a lot more work going on by the Food and Agricultural Organization in helping farmers in developing countries raise chicken without using antibiotics. It's a little challenging because countries normally compete on this stuff, so them doing better is like a zero-sum game. But we're trying to get around that to see that there's cooperation here going on here. There's a lot more, there's a very interesting research mechanism now for AMR, which really should be copied for any other place. So the Europeans started this. The US is not yet part of it, but it's really like a joint programming initiative. About 30 countries pool their money into one research funding mechanism. The rule is that this is all peer reviewed to the same standard, but every country's scientist will get the exact amount of money that their country put in back to their own researchers. So there's that caveat. But barring that, you have great international research that happens through a mechanism like that, which is because there's no point the Chinese working on a problem and the Israelis working on the same problem without having really talked to each other. So we're trying to figure out things of that sort. I'm optimistic. The fact that this whole thing happened, in the US, $1 billion on AMR, I could not have dreamt of this 5 years ago. There's a presidential advisory council on this. This administration takes AMR seriously. It's now, this whole advisory council is now written into law by the Congress. So I think we're making good progress, but this is a really tough problem. It's multifaceted, it's got animals, the environment. We haven't even talked about sewage treatment, what our standards should be for sewage treatment. Should we have sewage treatment that takes care of residues coming out of hospitals, for instance. So a lot more to be done, but a lot more international cooperation than we've had in the past.
Okay, let's thank Ramanan for one more.
What took you to the hospital in the first place? They've not caught on to this yet. It's like a early stage of So
Right.
Oh, I see.
Definitely agree. We actually had a student last summer that our office funded to work with an Indian